Hi, welcome to our second video here. This video, we're going to be talking about different ways to display quantitative data. It's categorical last time, quantitative this time, and this time we're going to get to use our graphing calculator. So maybe pull that out before we get too deep into this, but I'm going to continue ahead. So caffeine's great, except for it can be not so great. Too much causes a lot of issues there. But let's say we took a sample of 17 common soft drinks. Soft drinks is just a fancy word for soda. And this is the different number of milligrams that each of them had right there in that table. Now, sometimes when you're given a data set, the very first thing you're going to want to do is actually put that data into your calculator. So that way it's there for you and you can sort of utilize it to find and create different things that you might need. So let me show you how to do that, okay? So what you're going to want to do is you're going to want to get your calculator out and turn it on, and might have stuff on it, might be completely blank, but let me show you what we're going to do. In order to enter data, we want to press the stat button right here underneath delete. Press stat, and in here, there are three menus: edit, calc, tests. We're gonna end up using all of these throughout the year, but really the only thing we use too much often in edit is actually that first one there, the first thing there, edit. You can hit enter, you can also hit the number 1, and it'll take you to a bunch of lists. That's what all the L's stand for, is lists. And so we're gonna enter our data here into list 1. You might have some data in the other list. It also might be completely blank. If you ever want to get rid of the data that's in a list, you're gonna want to go and up to the list and actually highlight the list name. And you want to press the clear button, not the delete button. If you press the delete button, that list goes bye-bye. It's not gone forever, you can get it back, and if you ever do accidentally do that, feel free to ask your teacher to help you restore that list. But if you hit clear, you can see at the bottom here, it is now cleared out, and when you hit enter, it actually clears out the whole list. And you can do that with any list that you have. Clear, enter, arrow over, clear, enter, not delete. Delete actually deletes it, not clears it, and you just want to clear it, and you can check to see if there's any other lists. So let's go ahead and enter the data for this stuff here, okay? So in order to enter the data, I'm going back over here to list 1, as you can see, and all I'm going to do is just type in the number and press enter after every single number. So I can see on my list, I don't have it up right now, but you should see it next to you. I got 19, 15, 23. You can see each time I'm entering it, it puts the data value down here, and when I hit enter, it adds it to the list here. I'll keep going: 23, 19, 23, 31, 23, 24, 27, 34, 36, 25, 45, 27, 27 again, and 25. And what I like to do before the last one is I always check to make sure, because the number next to L1 tells you what entry number it is. So in the original problem, it said there were 17 drinks that we were looking at here, and I am in entry number 17, so that means that I got all of them. If I accidentally had 16, that means I missed one in my sort of entry, or if I was at 18, it means I maybe duplicated one. So I always like to just double check that, make sure that I have the appropriate number, which is 17. So there, it's all stored into our calculator for us. So let's go ahead now, set that off to the side, and return to our notes. So some different plots that we can do here. We don't really call these charts when it comes to quantitative data. We call them plots. And so the first one we can make is something called a stem and leaf plot. This is a display that shows both the distribution and the individual data points there. And so it's called stem and leaf because they're sort of like these stems to our values and then the leaves. So over there in the little box, it's got some sort of different things to remind you of. So first off, this stem plot will show you a lot of info. It's got all the original data all in there. It's great. But it's only really good for you to make this if you don't have that much data. 17 is not too bad, so we can go with that. But sometimes it can be a little bit obnoxious if you're dealing with hundreds of data points there. So only do this when you're dealing with a smaller amount of data. The next thing is you're really aiming for like 5 to 10 stems. sometimes when your data, you're like, oh, I don't actually have like 5 to 10 stems. I have less than that. What do I do? How do I fix that? And that's something that is called sort of splitting the stems. It's something that you can do. So we'll get into that in just a moment to help you out. And then don't forget to make a key for your display, okay? So you sort of have to explain what things mean. Your calculator, by the way, can't do this, okay? So this is something you do have to do by hand. So that's important to keep in mind. So let's go ahead and get into this. So stems, the stems of this, I figured that out by actually thinking about what my leaves are. The leaves are always the last digit in your data there. So my leaves are gonna be like a 9 and a 5 and a 3. So that means everything before that is gonna be a stem. So I can see here, I've got 10s, 20s, 30s, and 40s. Those are the different stems here, my 10s through my 40s. Note that that's only 4 different stems. So what I can do here actually is split these stems. And I can do actually 2 different ones. So to get me started, I'm gonna go ahead and do that. So I'm gonna go 1, 1, and 2, 2, 3, 3, and 4, 4. And you might be going, well, why are you doing 2 of them? Are you duplicating them? No, what I'm gonna do is split up the 10s, so that way 10 through 14 go into the first 10 column there, and then 15 through 19 can show up in the other one. So this gives me a chance to sort of get a little bit more of a better view of what the distribution actually looks like. So now I'm gonna go ahead and start filling in the leaves. So I'm gonna go in through and go like, all right, do I have any 10s, 11s, 12s, 13s, or 14s? And I'm gonna do this from least to greatest. In this particular case, I do not have anything that's 10 through 14, so I'm not gonna put anything in that first one. What I can do though is put in a 15. I do have a 15, and I have 2 19s. I like to cross them off as I sort of go through them. So in the second one, 5, and then a 9, and then a 9, like so. Now my 20s, do I have anything from 20 to 24? I sure do, okay? When I'm looking at this, I see the lowest one are some 23s. I got 1, 2, 3, 4 of them there. So I'm gonna go ahead and write in 4 of them. Notice how I'm sort of making them like the numbers the same sort of size as we go out there. And then there is a single 24 right here. So go ahead and put that. I think you probably get the idea. Why don't you go ahead and try to finish it up? I'll keep going here, but I'm just gonna shut up for a little bit and start filling this in. All right, so there you have it. If you need to pause and finish yours up, go for it. But I'm gonna go ahead and continue on here. So that is splitting the stems. You don't always have to split the stems. So if it turned out I had caffeine that was in the teens and went all the way up to the 60s, then that would have been enough for the 5 to 10 stem total. But you know what? Ultimately, if you don't find yourself like you didn't notice, like, oh, I only had 4 stems and you're supposed to, I'm supposed to have 5 to 10, it's really not that big of a deal. A lot of times there's some wiggle room there. Another thing we want to do is actually give ourselves a little label here. So this is caffeine in milligrams. And then you can see here it says make a key for your display. What does that mean? Well, a key is just sort of like a way to sort of read this, because if somebody was looking at your stem plot and they might go like, what am I even supposed to be paying attention to? How do I know what something is or is not? And so in this case, I would just grab one of these data values in here to sort of show it off and show what it sort of looks like. So like, for example, a 2 and then the vertical line 3, which we can see like right in here, right? That represents 23 milligrams of caffeine. So now somebody can read this and hopefully be able to take that and read other things there. Know what a 3, vertical line 6 would mean, or what 1 vertical line 5 means. So there you go. So there's our stem and leaf plot. Yay! If you need more time, pause. We're moving on to dot plot. So a dot plot, that is where there is a dot graphed for every data value along a line here, usually a horizontal line. I just realized that says dingle and not single. I'll fix that before I print it out for you all. So single line for each data value, you stack repeated values, and it's supposed to show it. This is pretty good for smaller data. It's not very helpful when there's not a lot of repeats. Otherwise, you're just looking at a big, long line, axes with just like some dots that are sort of there. So when there's repeated values, it's helpful. Don't forget to label your axis. And again, your calculator can't actually do this. It can't make a dot plot. It can make something very similar, but not a dot plot. So to do this, we're going to go ahead and first draw ourselves a horizontal line. And we're going to go ahead and we're going to scale this. And so I'm looking at my data. I see that 15 is the lowest, 45 is the highest. So what I'm going to do is try to make it so that way I can get in all those data values here. So I'm going to come over here and put in like 15, call that 20, 25, 30, 35, 40, 45. And then I'm going to label it. So this is caffeine in milligrams. Can't forget to label it. And then I'm just going to put a little dot for every single data value that I have. Now, what's nice, if I've already made the stem plots, that means I can sort of quickly make this dot plot without too much trouble here. You can also use X's instead of dots. That's also totally fine. So I'm just going to go ahead and make it. So we have one value at 15 and a couple at 19. So I'll go ahead and do that. And you can see I'm stacking them. A few at 23. One at 24. 25. Oh, there's just two 25s. So go ahead and fill yours in. And there you have it. So this one didn't have a ton of repeats, so I don't know. For me, this isn't like the best visualization of what our data looks like, but that is what a dot plot is. Again, if you need to finish up, pause. I'm moving on to histogram. Histogram. So this is a lot of the things that we tend to look at more frequently than the other ones. You've probably seen many histograms in your life. And so the idea is that you sort of like a dot plot, except for instead of looking at just individual like ones as sort of your repeating values, if anything falls into like a little interval, so from here to there, well, then you're going to stack up things here. And just like with stem and leaf plots, you're going to aim for like 5 to 10 of these, what we call bins or sometimes buckets. So some things to note before this. So this is great for when you have more data. Okay, this is easy to deal with because you get to use your calculator. So some words of wisdom. Each interval includes the lower bound, but not the upper bound. So for example, in this very first bin from 15 to 21, 15 is included in there. So that's the 15 data point that we have is in that bin. If we had a data value, though, that was 21, it actually doesn't go into this bin at all. It actually would go into this bin. So in reality, we're talking about everything that is greater than or equal to 15 and just less than 21. So if there was a amount of caffeine that was 20.9, that actually would go in this first bin here, not the second bin. But 21 goes into the second bin. So you always include the lower bound and not the upper bound. And then never forget to label your axes. You can see I have caffeine in milligrams down there. It's perfect. I also have frequency because this is raw counts. So it's already here for us. And you're like, well, what's that all about? Why are we doing that? Why not create it? Well, creating histograms actually is very difficult to do by hand. And pretty much, we're not going to ask you to do that too often. Instead, what we'll let you do is use your calculator to do that, okay? So let's look at how to use our calculator in order to do that. So let's go back to our calculators here and take a look at that. So turning back on your calculator, remember we stored all the data in list 1. So what we want to do is we want to create a little stat plot, which is right here in blue above the y equals button. Why is it in blue? Well, it's because you need to hit the second button and then hit the y equals button to go to your stat plots. And so you can see here that there is the option to have, it looks like 5 different plots here. I usually only ever have like 1 or 2 kind of going. Right now I have 3 for some reason. Oh no, there's 3, sorry. 4 and 5 will turn off all your plots and turn on all your plots, that's right. So we're gonna go to number 1 there, press 1 or press enter. And I'm gonna turn it on. And I want to create, so there's different ones you can create. This is a scatter plot. This is like a line segment plot. We'll talk about that maybe at some point here. That's a histogram. These other ones are box plots, and then this is something called a normal distribution probability plot, if my memory serves me correctly. Here's where we're going to enter in what list we want to plot. We put all of our stuff in list 1, so we will do that. If for some reason you happen to have something else there, there's an easy way to get in the other lists. If you go to the bottom down here, you can see in light blue, L1, L2, L3, that's how you can grab your other list. So if it turns out list 1 was not in there, you can hit second and then number 1, and then it would put in list 1 for you there. Frequency, don't worry about that, leave it as 1. You can change colors if you have the fancy colored one here. And then we're gonna go ahead and go to graph this thing. Before you just go and hit graph though, that could be a bad idea. Sometimes the graph is not centered where you want it to be centered. So you could spend some time in looking at it and go like, okay, well I want the x-axis to be from 15 to 51 or whatever it is you're dealing with. That's a big pain in the butt. The zoom button fixes that for you. If you go to zoom, there's all these different sort of ways you can sort of center your axes and zoom. The most important one is this last one right here for our class, zoom stat. What it does is it takes the plot that you're trying to plot and it figures out the best X and Y scaling and window for you. That way you don't have to deal with it at all. So hit 9. If for some reason it didn't work for you, some of the older calculators do a weird thing when you hit zoom 9, it does something weird. You can just quit out. To quit, hit second and then the mode button, and it takes you back to the home screen, and then you can hit zoom 9. And there you have it. It has there the histogram that we would want. Fun thing is like you're looking at this and going like, well, how do I tell what the numbers are? That's where our trace button is really helpful. When you hit trace, a little cursor pops up. And what it does is it tells you the bin that you're looking at. This is the bin from 15 to 21. Notice it has the less than symbol there, so not quite to 21. And then it tells you how many data values fall in that bin. There are 3 of them in here. And you can arrow left and right to go to the next bin, 21 to 27, 27 to 33. And so on and so forth. So there you have it. That's how you make a histogram in this. So feel free to try it out on other things if you want to find some other data values and try to make some other ones. We'll definitely do more of this in class. Let's return to our stuff here. So that was histogram. We're flipping to the backside. Relative frequency histogram. This one, your calculator, well, I'm going to tell you what it does. So first off, instead of talking about raw counts, we're going to talk about percentages or proportions. So if you remember from categorical variables, we had the just like frequency table versus a relative frequency table. So now here we're dealing with the percentage of all of these that fall in here. So instead of saying 7 occurrences are falling between 21 and 27, now we're looking at this and going like, oh, it's like, 41% are falling in that bucket there. So again, this is great for medium to large size data sets. This is actually very helpful when you're comparing two different distributions that have different sample sizes. So if you're dealing with something where it's like 17 soft drinks, and then it's like looking at, oh, and then there's these, 34 energy drinks. Like that's not easy to compare raw counts to each other because they're different number of things that you're looking at. So relative frequency is good for that. Same, 5 to 10 bins. You can use your calculator. How do you use your calculator? You just type in the frequencies. So looking at your old histogram, you go 7 out of 17. You just do that in your calculator really quickly, and then it tells you, oh, that's about 41%, and then you just plot it. So yeah. Notice that this looks identical to this one here. The shape of it all, like sort of how high the bars are relative to each other, all the same, which is what we noticed with relative frequency bar charts last time. So that is what's going on there. You don't have to make a ton of these here. It's usually histograms. And again, you would let the calculator sort of do it for you. Last thing to talk about, kind of a different animal altogether here. And there's a lot of questions you'll try to answer on your own here. So this is called a cumulative relative frequency plot. It's a mouthful. And so what it does is it sort of tries to plot along different values and like what percentile those different values are in. So one way to sort of think about it, every single point on there, an x comma y, means that the data point of x, the data value of x, has y% of the rest of the data that is equal to or less than that data value, okay? Or that the x data value is in the yth percentile. Kind of funky here. So an example that I have over here, so in this example, there we have the point 30.6. So right there is the point 30, 0.6, okay? That means that, so by the way, what we're looking at here are some different drinks here that are talking about sugar content instead of caffeine. Okay, I should have talked about the context before we did that. So here, a drink that has 30 grams of sugar is in the 60th percentile, okay? Well, what does that mean? We're gonna answer question A together, but then I'm gonna leave you off to answer the rest by yourself, and we'll talk about them in class. What does it mean to be in the 60th percentile, okay? What that means is that all drinks sorry, let's erase that. I don't like the way I'm answering this right now. We'll go ahead and try this again. What this means is that 60% of all drinks in our sample, I wouldn't say all drinks ever in the world, just in our sample here, have 30 grams of sugar or less. So less than or equal to 30 grams of sugar. So that's what it means to be in the 60th percentile. You know, some of you might be taking some different tests and things like that, and you get thrown back. It's like, hey, you're in the 53rd percentile. What that means is that 53% of all the people that took the test scored at your level or lower, okay? So essentially, like you're better than 53% of the rest of the people that took the test. So there's some other questions here that I want you to answer and spend some time on there thinking about these. So answer those 4 questions. Come prepared to share them with your neighbor when you come into class, and we'll talk more about making quantitative displays.